Hi, we've finally gotten around to Hopper on the MECB 6502 machine. So let's have a look at that. So it's this machine here. I really like it. Backplane machine, lots of potential, very configurable, and rock solid in terms of how the cards plug in compared to, say, the RC 2014 approach with the header pins. I really like this board. Highly recommend getting one from Digicool Things. Anyway, let's get Hopper on it. So just before I started making this little series, I did a release of Hopper, which has got all these updates in it. So the latest release on the GitHub repo for Hopper is this version. So you followed me on my journey through getting the drivers to work for the I/O, for I/O and time, and for serial I/O, parallel I/O, and time. So now let's see how you get Hopper to work. So the way you build Hopper for a 6502 machine is you load up under source runtime, you load up R6502, which stands for runtime 6502, and then you just build this F7 to build. And it used to have a whole bunch of configuration in here. Right now, it's pretty much you don't configure anything in the source. Instead of configuring in the source, what we did is, and this is when we were putting it onto the second machine, Dave's 6502 retro bank memory machine. We came up with configuration files, and then I used them to make it the same configuration files to make it work on Ben Eater's breadboard machine and also now on this machine. So we built it. So let's do a 6.5 DASM of R6502 to see how big it is. We want to make sure that it's underneath the 16K ceiling. And there we go. We've got 1296 bytes free under the 16K ceiling. And that's because even though the default that the CPLD comes with for this device is 8K ROM and 56K RAM, I've programmed mine over here to be 48K RAM, 16K ROM. So I have made a smaller version of Hopper that's less functional. It's got less features, but it will run in 8K. It's got the bare necessities to make a decent system. But let's go and have a look at the configuration file. So if you look at options, configuration.options. This is the default configuration file to build Hopper for my machine. So for my single board computer, this one, the Hopper 6. And there's a whole video series on how you build one of those yourself, how you get the PCB and all that. So default is 8 megahertz, 0 page I/O. I've got my I/O on the 0 page. And then these are the other options here. I've got a VIA for parallel. I've got the same serial ports. I've got I2C, and we comment out all of these other options if we wanted to fit into 8K. Now what we did is every time Dave pulled from the repo, he had to go and redo his config file. So we made a second one that's ignored by GitHub, and it's your local one, so that you can have your own settings that override the ones. So the settings in local override the settings in options. And I'm turning off various options. So I'm turning off 8 megahertz and choosing 4 megahertz instead. I'm turning off the VIA from the other option and then putting on the PIA, etc. Getting rid of the 0 page I/O addressing, using the I/O addressing from from this board. So yeah, that's the configuration you got to do before you build the Hopper project. You got to do configuration for your specific board. And I'll leave this up like this. So this can be. We'll remember this for reference if we ever forget how to build for this board. I don't think we will. Okay, let's burn the ROM. So let's go in there and go and find R6502. We want it to start at 8000 hex because it's 32K ROM, and we want to think that the ROM, so it's in the top 32K, so it starts. And there's the vectors. I always like to scroll to the end so that we can see the vectors in the last 6 bytes. And we shouldn't scroll up too far here before we start seeing code because we've only got like just over 1000 bytes free. Okay, let's program that. And then I'll pause the video and plug it in and turn it back on again. All right, we're now running again. And with all the other demos, if I turn the power on, you'd see blinking. With this one, you won't. Why is that? Well, that's because there's no Hopper program on it. There's only the, I've only got the runtime on it. But let's go have a look. So if we go at the console, we go Hopper Monitor. And then we say M0, that shows us the 0 page. We can look at various of the flags, so it shows us what the heap size is. And so Hopper, this is the Hopper Monitor, and this question mark shows us the help for it. So Hopper is running on it right now. It's just not very exciting. So now we go to, let's go and see where I've got some sample code. Like that. No doubt I have a Blink program. Yes, I do. So these are the various different boards we're currently supporting. So we've got four different flavors of 6502 boards so far. And if you go and look in the board definitions, all it's doing is setting a couple of constants to say what the devices are, where the ports are, what the address of the ports are for the I/O functions and things. So anyway, it's similar to the way Arduino does board configurations, and that's obviously where I got the idea from, because Hopper runs on RP2040 boards, so this is the PiPico's definition, board definition. So the same code, you can build the same code to run on, say, a Raspberry Pi Pico. Platform works. There we go. That's the API to do turn the LED on and off, and it's writing seconds out. And this time, of course, we have the whole Hopper runtime, so it can write them out in decimal. So let's build that F7, same as building assembler, but now we're building Hopper high-level language. If we press F5, it should load it up onto the board. There we go, uploading, successfully uploaded. When the title bar changes to green, we're in the debugger. So if I control F5, it'll run without the debugger here. And there we go, we've got blinking and we've got seconds coming out. So I've been yakking for 2 minutes since I turned the power on. And each second should pop out twice because it's 500 milliseconds. So we should see each number appear twice. There we go. If I control C that, and now if I F5, I'm now running in the debugger. And so now if I say control C and break, it breaks in the debugger and I can single step now. So I can step into what does that LED property do. It sets pin mode. What does setting the pin mode do? Step into there. It's, you know, doing all the data direction register stuff, that control register to pick, you know, which port it's looking at, etc. And the same is true of digital write and digital read, which are used by actually, you know, setting the LED. Actually, we'll go back up here. So it's gonna, let's put a breakpoint there on digital write, F5. We're now at digital write, step into it. And again, you know, it takes a GPIO pin, converts it to a port. It's going to be one of two, A or B. And then based on that, chooses which control register, and then uses that control register to correctly select the port, you know, the right port register. And not the port register rather than the DDR register, data direction register. And then based on whether the value is true or false, it'll either set or clear that bit and using memory read and memory write. These APIs can read and write the entire 64K of the 6502 memory. Anyhow, there you go. Hopper configured and up and running on the MECB boards, on the 6502 board. I can highly recommend this board. It's been a pleasure to actually build the kit. I had a little bit of difficulty with the, you know, this set me back a little bit, the connector, but I don't think it's any fault of Greg's. I think it's just there's no standard. And we went and checked afterwards. There is no standard. So I think if it's well, now that it's documented, it's going to be a cakewalk to for the next guy. And like I said, I highly recommend signing up. If you buy one of these boards, you definitely want to get on the Digicool Things forum, because it's a really nice community, very supportive, and they'll help you get this up and running. Okay, what's next? Well, there's a sound generator chip in here, and Dave and I have been playing with sound generation. Well, he has with video game music, VGM. So that's probably what we'll do next. We'll get sound on this board. Thanks for watching.